Hello and welcome to the RedMars podcast. I'm your host, Astro Jake, and today we're going to do a little bit of catch up. It's been a while since I've done one of these podcasts. Reason being, I've been traveling all over the place for work, and I've been working on some projects on the side here that I'd like to kind of talk about here and let you guys know what I got going on. In particular, this little box I have sitting here. So I've been working on something that I want to give back to those and provide to people looking to get started in this field, whether that is, electronics or software engineering or some other area of STEM, to help them on their career to a space-related job. Now, I've got a very diverse background, mostly because of how I was raised, coming from, electronics and stuff like that, and then working my way into the computer science field and whatnot, and then kind of indulging in the space industry before I actually officially was hired in this industry and doing my master's and whatnot. And combining all those worlds together, I realized that there's a lot of opportunity for others to really dip their feet into many different areas that help them build up that resume for doing space-related jobs. Because for those that work in the space industry, not necessarily defense. Defense, I would say, has very siloed, one-hat style jobs, but if you're working in a human spaceflight style role, you'll find more often than not you have to wear many hats. So maybe you are a software engineer, but tomorrow you're working on assembling some sort of computer system, or maybe you are an electronics engineer, but you're tasked with writing some code. Or maybe you're a mechanical engineer and now you must do some other unrelated task, or maybe not directly related to your skill set and whatnot. So I'm looking to build these types of educational kits that help those kind of upskill or dabble in different areas, starting with what I know best, and that is computer science and electronics. So I will start by sharing with those who are watching the podcast here what my website looks like to help you navigate kind of what's coming and see what might be down the line. This is where I try to keep the most up-to-date information with what's going on, as well as any updated podcasts and all that. This is kind of a one-stop shop for everything. So my website is www.redmars.com. And as you can see here, for those that are watching, this is the landing page that you get to. It is all about my podcast. I have my most recent YouTube videos shown here, featured videos and whatnot. And I go through here and just, it's kind of my place to have fun with what things look like. I did a bunch of web design early on in my career, well before I started straight computer science. It was just kind of an interest of mine. Did it in high school as well. And that and robotics, actually. I was very lucky in my extremely small hick town school that they had a robotics and kind of computer science program. And to give you an idea, I was the only student in my grade 12 robotics class. So very thankful to the professor that helped me along the way there. And really that helped me kind of grow into the role that I have now. Obviously, I took quite the path for those that know me on how I actually got here, but I'm here now and I am enjoying it. So anyways, here is the main page, my podcast, and I go through all the different descriptions of what there is, then some of my information at the bottom, if anybody is ever looking to get a hold of me. Now, up at the very top, we have this new section on the top right, and it's called RedMars Labs. And this is where I've gone very big into that retro wave, very Miami-ness look. And I'll click on it here so you guys can see. And this is RedMars Labs. So this is all about learning to build and then building to explore. So really targeting those that don't really have a background in this field and want to learn. So I've looked at other kits out there, and I was interested in like Arduinos and stuff like that and seeing what they had to offer. And a lot of these kits are quite expensive, and you don't get a whole lot. Now, there's tons of tutorials for all these things, so I wanted to find a way. How can I provide to my viewers or anybody really that's interested a educational kit that gives you what you need to get started? And that's kind of what got me down this path. Now, at the very top, obviously, always welcome to those that would like to contribute and help out not only the channel, but give me more time to put more effort into these. I do work full time and have a family, and it keeps me very busy. But in the off hours of the early hours of the morning and late at night, I like to work on things like this, and I will open this box and show you what is inside. Now, we do have that support button here, so if you ever do support, I extremely appreciate it. Obviously, you don't need to, but have that here for those that anybody who might feel compelled to do so. So here we talk about kind of what the RedMars Labs experience is about, talk about what my background is and kind of RedMars as a whole, what our beliefs are on helping those individuals kind of get started, and then why you should choose RedMars over, say, a Amazon kit from Arduino or something like that, where you'll easily spend over, $100, $200. Now, all these kits that I provide are obviously fully integrated and usable with any Arduino parts, and we'll talk about that and why they are. Anything that is labeled Arduino and communicates with those Arduino boards really are not unique to them. They're just advertised in that sense that they can only work that way. Now, all sensors can really be used with anything, and the only thing that stops you from being able to do so is your own level of knowledge on that topic. So we will talk about that. And all right, so as we scroll down, I created a RedMars LLC GitHub project, so I will be uploading all kinds of code and repos and different types of information there, not just for the hardware level electronics and hardware level types of code. I'm also for those that are more interested in, say, like Java or other, I won't say higher level languages, but non-hardware languages. I will have other things posted on there, maybe something to do with your traditional LAMP servers or microservices and whatnot. I've been working on one that'll be a GraphQL server, just as a tutorial for those that are looking to learn about what GraphQL is and how you work with that. That's another thing. And just kind of as I have time and build out these little prototypes or different tutorials and sample pieces of code, I'm going to be putting them on here so that anyone else who is interested can go in and learn how these things work. And obviously, if you feel like you can improve the code, always open to suggestions and those merge requests or pull requests in order to update that code base. So, moving along, we have these builder kits that are coming soon, and that is this box that I keep showing everybody here. This box, my mysterious box of goodies. So to start off, we're going to have two kits here, which is the ESP32 Tinker Kit, which is an Internet of Things style board. It provides Bluetooth and Wi-Fi interfaces, and it'll give you some very fun out-of-the-box capabilities to build, say, a server where you can control sets of LEDs and buzzers from your cell phone wirelessly to this device and this development board. The other one we're looking at is a wireless infrared communications kit that allows you to build kind of a TV blaster from your computer using a small little Raspberry Pi style Pico board. And these are all MCUs. They're microcontroller units, so it's not high level. You're not running a Linux operating system on these things. You are actually writing code to run on the microchip itself. And I'll do another video that goes a lot more in depth on each one of these, including tutorials and whatnot, once these are available. I am aiming to have these available within the next week or so definitely stay tuned for that when I release this. Another kit that I thought would be fun to do for others that are not looking to really get hands-on like this and build electronics and robotics and whatnot, and these real hand-level development kits. So we're looking at building a back-end server or something like that. I used to work a lot on back-end servers when I worked for JP Morgan Chase, and I took care of the authentication platforms for when you swipe your card and you get charged or you get that approval. That approval then flows through our systems and whatnot. I won't go too much into detail, but that is what I did, and it was a lot of back-end work, and there's a lot of jobs in that area, and it is a very good skill set to have. So I have a lot of experience in that area, both from before I moved to the U.S. I've done work like that in Canada for billboards all the way to banking systems and now space systems. So I have a lot of experience in that field across many disciplines, so I would love to share some of that with everyone here that is also interested. So I'm looking at building out another kit similar to this, same style of size, whatnot, but that one will run a Linux operating system that allows you to build a standalone server, maybe something like a Raspberry Pi, a full-blown Pi or something like that, that has the chipset to support. We'll see what I can come up with. My whole idea here is to keep costs down. I do not want things to be expensive, and that is why I'm looking at this. So if you bear with me for a minute, we will get started on this, and we'll open up this box and see what we have in store. All right, so let's take a look at what we have inside this box. All right. So as you'll notice when you first open up, we have a QR code here, and what this does is bring you back to my website here, the RedMars Labs, and RedMars, and this allows you to get access to all of the code links and everything like that here, and we'll have more information here as well on how to get to the resources needed for your tutorial and for your kit. So let's go through what some of these items are. We have a little baggie here full of all your components to get you started. You have a USB-C cable here. You have a small little breadboard here that allows you to do some prototyping. Then we have your main control board here. This is your ESP32. This is the S3 model, so I'll zoom in here for you. Let's see if I can get this so you can see. Yeah, you can kind of see there. So as you'll notice, though, there are leads in here. They are not soldered. I have them like that because some people might want to learn to solder themselves. So these are very easy to solder on, very friendly in that sense. But if you would like to have them pre-soldered before you take delivery of your kit, just let me know and I can definitely solder them for you so that when you get your kit, the leads are soldered and ready to go, and I can solder them either on the top of the board or the bottom, depending on how you plan to use the board itself. I personally solder them on the top with the long part on top because you will have these wires that are female on one side, male on the other, and that allows you to put your wires on top of the leads while keeping the board in its upright position. And yeah, with that, you have a couple sets of these for wires to make those connections on your board. And then I'll also have some other smaller components and little knickknacks here and there that I find might be fun to experiment with. And I throw that in this little baggie here with some of your other components. Just to give you an idea of what this one has, we have some capacitors. And just for your information, some of these items you might not know what they are. There will be a small document that is included with your kit that explains what each of the components are and the quantity that comes with them. There'll be some sample schematics and whatnot that allow you to prototype and build out those sample projects. So we have some capacitors, we have some resistors of different values. There's a buzzer, we have some LEDs, we also have, what do we have in here? Some photoresistors. So pretty much these are things that react to the light. So if there is a light shining on them, then current will pass through. If the light goes away, then the current stops, and it acts as a resistor. So it's not a on-off style of component. It is a throughput. Think of a hose, and as you squeeze the hose tighter, less water flows through it, and as you expand that hose, then more water will flow through. So it's controlling the flow of electrons through it based on light. I'm not sure if I mentioned there's also a buzzer, but we have several LEDs in here, smaller LEDs that are red, green, blue, yellow, and clear, and then also threw in some other larger LEDs that are also clear. And that's what's in this one here. This is for the Internet of Things style of kit, so there's a lot of code that you can do with these that you actually don't need any components, and you can kind of see how they work. Because it has Wi-Fi and Bluetooth, it allows you to communicate with many different other items, such as other wireless devices as headphones or your cell phone itself. You can run a server on them, very lightweight, since an ESP32 doesn't come with a whole lot of processing power when it comes to kind of interfaces and servers like that, but it does work very well for Wi-Fi and Bluetooth communication. So these work well if you're trying to build an LED control board or some sort of integration with some hardware when you want to control it with a cell phone, a computer, or over a Wi-Fi network. It gives you a lot of that ability. So they're great to use. They're very versatile control boards here, and that's why I thought this would be a great little project. So my idea for these, and don't hold me to it, I have to go through it, but my idea is to sell these for around the $35-ish range, and you get everything you need to get started. Again, I will solder the leads onto the ESP32 if that is what you would like, or I can leave them on for those that are looking to kind of solder them yourself. Now, there's no fee for me to solder these on. There just might be a little bit of a delay to get them included. Obviously, if there's some other work you'd like me to do, we can look at that. But for now, these are going to be as they are kits, with the exception of soldering on those leads. And I might take that back. It probably takes some time to solder them. Maybe there'll be like a $2 charge. I don't know. It won't be much because I want these to be affordable. And it does take some of my materials in order to put that and solder those together. And time. So obviously, I'll keep it cheap. We'll be under $40 for everything. So these are the kits that are coming your way. So there's this one here. Then, as I mentioned, there's the Pi Pico version of it, and that's focused on infrared. So we'll kind of have some projects in there for like a TV blaster that allows you to turn your TV off and on from the code that you write, and also has some other components in there similar to what you see in here, but not from the wireless perspective in terms of Wi-Fi and Bluetooth, but from an infrared perspective. So a different medium, but a lot of fun still. And that's kind of what we're looking at. So that's your two kits to start off: the Internet of Things ESP32 Tinker kit, and then the wireless IR communications kit with the Pi Pico. And you get this fabulous little looking guy here. And yeah, I thought it would be a fun little theme for the box here. You got the little RedMars logo all over it. Looks pretty cool and retro wave if I do say so myself. So that's pretty much it. I just wanted to go over some of that stuff that I'm working on right now. So I've been busy working on all this, figured I'd focus some more time on that and then come back when I was ready and have one of these conversations and podcasts with all of you. Now with that, what else have I been up to? Well, I mentioned with work, I've been very busy lately, traveling around a bunch, spent some time in Seattle, where I can't talk too much about what I was doing there, but I was also just recently in Houston. I wanted to share some cool pictures that I am allowed to share of the facilities there. So this is at Johnson Space Center in Building 9, and this is where they do their astronaut training for the International Space Station in 1G environments. That's 1 times the gravitational constant. So what you and I experience right now while we're watching this video, unless, of course, you were floating around in space or experiencing some sort of micro or other G for if we got extraterrestrial life forms on a different planet that is larger than the Earth. Anyways, this is where I was. And it is very cool. You can see all the different modules that make up the International Space Station and some of these compartments here. If you can see my mouse, these compartments are where they fill with all types of electronics, experiments, and whatnot. And these line the walls of these modules. You can see the outside of them are curved, and then the walls themselves are straight. And that's what forms that kind of square tunnel inside the space station. If you've watched any videos from the space station, you'd recognize what these look like. Now, if we kind of scroll here, you can see here's an EVA, that's extravehicular activity. These are all the activities that happen outside of the space station, or outside of a spacecraft, and these are the suits that they wear. Very cool. This is one that they allow people to get in and out of at the International Space Station. Or not the International Space Station, sorry, at Johnson Space Center. Wow. I guess if you're on the space station, you'll get in and out of them as well if you're going to do an EVA. So I wanted to share that with you folks. Here's kind of what it looks like when they're doing one of their training sessions. And here is inside one of the hatches. So this is kind of what I was showing. You have these squared off walls and whatnot. This is with a hatch though, so a little bit different. Do I have an image here? This is actually the Soyuz. So this is an old Soyuz that they would use, kind of see how much space you actually have if you're going to hang out inside of one of these on your way to the space station. So a few days to stay nice and cozy with your partners and compatriots. So got 3 seats here. The left and the right are the mission specialists or whatnot, and then the commander of the mission would sit in the middle, and they're the last ones to get in. Interesting thing is the 2 outside folks get to be strapped in and really pulled tight. And then the last one here, the commander comes in, has to strap himself in because there's no room for somebody else to get in there and pull the straps tight. So you better know what you're doing. What else do we got? Here is the NBL, November Bravo Lima, the Neutral Buoyancy Lab. And this is where astronauts go and train in the same kind of modules that I just showed from Building 9 at Johnson Space Center. But this is where they train for those EVAs, those extravehicular activities outside of the spacecraft. So this is all underwater. I believe it's 40 feet deep. And they will go and practice in this facility as if they were in microgravity and perform whatever it is they need to perform outside of the International Space Station, or other spacecraft can also be put into this facility and used to run through training events and procedures and whatnot before they actually end up on orbit doing those tasks. So this is a really cool facility. You see lots of cranes here for suited events when they're dropping very heavy individuals into the water. And I mean heavy because they have a lot of equipment on their person, and that's what causes them to need these cranes. A spacesuit with a average person inside would, I think they can weigh, 500, 600, 700 pounds. Very, very heavy. But obviously in a microgravity environment, it doesn't really matter so much. So, so this is what it looks like. You see some of the modules here, and obviously they're focused on the external part of the space station. So the internals of the mock-up aren't as important here, as they'll be doing extravehicular activities training here. So very cool. Water's super clear. It's a really neat facility to experience and check out. And yeah, I was here checking out their training facilities. And that's all I'll really say about this. It was a lot of fun. I don't want to go too much into detail, but if you do have any questions about the facilities there, I can try and answer them to the best of my ability based on what I remember from my trip there last week, and happy to share those with everyone else. But yeah, with that, I plan to do some more podcasts moving forward on maybe some more of the stuff that I learned about there, and I'll be doing podcasts individually on each one of the types of kits and go through some tutorial videos and whatnot that will also be available on my YouTube channel for the RedMars podcast. And yeah, definitely don't forget to check out the newest part of RedMars. That's RedMars Labs. And let me know what you think. If you have any suggestions, ideas, any other kits you'd like to see outside of the IoT and wireless ones, maybe you want bigger kits, maybe more components. And let me know what your thoughts of a reasonable price for that would be. To give you an idea, Arduino makes one that's a couple times larger than this one, and they sell for around $240 with your Arduino kit. Now, I obviously, unless individuals are looking for kits of that magnitude, this is really all you need to get started, and I'm not marking it up too much from what I pay for all these components and the time that I put into this. If anything, if I were to take the time it takes of mine to actually build this stuff out, it's probably being sold at negative value. But I want to get everybody involved and really, figuring out what they like earlier on. And I think even if you are not in this field and you want to learn about this field, in electronics and computer science and programming and all that kind of stuff, this is a great way to get started and really see what it's like. So that's really my goal, is, promoting this area of STEM and just getting people involved at a young age so that you're best prepared when it comes time to look for that career. It took me a while to get to my career in the space industry, not in computer science and electronics and that, but in the space industry, from my side, mostly due to immigrating from one country to another. I originally come from Canada, so it took me some time. But if you are in a place where you can work on this type of stuff and you want to get ready for your career, you want to try something out before you go off to university, get a kit like this, see what you think. It's definitely not for everybody writing code. So you might find, hey, I really enjoyed assembling this stuff and all that, but I didn't like writing the code aspect of it. So then maybe you want to focus on the electronic side of it. But you never really know until you get your hands on and do it. So for me, I love the whole thing, the whole big picture, from writing the code to putting the things together to having it all come together as a full system. That's what I enjoy. So anyways, with that, I won't talk about this anymore. We'll get more information on this in follow-up podcasts. Just wanted to say I am sorry for taking a while to get back on these, but there's a lot of stuff getting ready for all of you, and I hope you enjoy. So don't forget to like, subscribe, follow along, turn on notifications on YouTube, and so you can keep track of when these kits become available. Definitely check out our website, redmars.com, and check out RedMars Labs. Let me know what you think. Anyways, take care, have a great rest of your day, and I will catch you on the flip side. Remember, stay curious, keep looking up. Until next time, see y'all.